In this representation, the orange pom-poms represent acetylcholine. The brown pipe cleaners represent acetylcholine esterase. The orange pipe cleaners represent acetylcholine-gated sodium channels. The calcium ions are purple pom-poms. The potassium ions are green pom-poms, and the sodium ions are blue pom-poms. The purple pipe cleaners represent voltage-gated calcium channels. The green pipe cleaners are the voltage-gated potassium channels, and the blue pipe cleaners represent voltage-gated sodium channels. The generation of action potentials within our nervous system is crucial to the functions of our bodies. Action potentials are passed through each neuron in our body, transmitting electrical message from one cell to another. In simple terms, these electrical messages are transferred down the long axons of neurons and are released across the synapse at a presynaptic terminal as neurotransmitters. They are then processed at the next neuron's dendrites, but this process is much more complex than it seems. A large number of voltage-gated ion channels are found in the cell membranes of neurons, which allow for the movement of potassium ions, sodium ions, and calcium ions into and out of the cell during an action potential. When a stimulus depolarizes the membrane to the minimum threshold of activation, sodium channels are the first ion channels to open. As sodium channels open, some sodium ions rapidly enter into the cell. Voltage-gated potassium channels open in response to depolarization caused by sodium influx. The movement of potassium ions out from the cell repolarizes the membrane back to its negative resting potential. In the neuron, voltage-gated calcium channels are only found in presynaptic terminals. Activation of voltage-gated calcium channels allows the movement of calcium into the cell. Calcium entry triggers the release of stored acetylcholine from vesicles in the presynaptic cell. A synapse consists of the presynaptic terminal of one cell as opposed to the postsynaptic membrane of the next cell. The small gap between these terminals is called the synaptic cleft. Acetylcholine is released from the presynaptic terminal. Only a small amount of it will reach the next neuron, as much of it is rapidly degraded and inactivated by acetylcholine esterase in the synapse. The acetylcholine binds to and activates acetylcholine-gated sodium channels, which allows for sodium entry into the postsynaptic membrane. In reaction, voltage-gated potassium channels are activated and cause potassium ions to leave the cell. From here, the entire process is repeated.